Hi everyone, and welcome to part 3 of my input-output expander series. In part 1 we were speccing out the project and came up with a first draft at a schematic diagram. In part 2 we moved on to prototyping the idea on a breadboard, just proved the concept works and decided on some current limiting resistor values. And now in part 3 what we'll do next is we'll take a look at designing a printed circuit board so that we can build up a really nice finished solution. So I'm using Easy EDA and this is what I've come up with. So I've got a board size of 46mm by 29mm and I've added some fixing holes at a pitch of 42mm by 25mm. So if we zoom in a bit, so we've got the main IC in the middle, and then on this side I've got a header for things like our power supply, data and whatnot. And then over on this side I've got the GPIO header for all our inputs and outputs. So these are our LED circuits, the two LEDs there. Here we've got a capacitor for the VCC pin on the chip. This is our voltage regulator with its two capacitors. So that's our little power supply. Couple of pull-up resistors here. I think one is for reset and one is for the A0 line. So if you have a look at the top layer here, you can see I've added the ground plane. I'm not totally happy with it because it hasn't filled this area here. And you can see here we've got a few like fingers in the ground plane. I don't know if they're a problem. And then we've got this little section here which is kind of isolated and not joined to the rest of the ground plane. So I've had to do something about that, you'll see in a bit. So these are the main GPIO lines, just going straight across from the chip to the header pins. I've done most of these tracks at the width of 0.3mm, and up here we've got the plus 5 volt where I've used a track width of 0.5mm. And this is the V-in line, again at 0.5mm. Here we've just got the reset line and the interrupt line. That's basically all the routing on the top layer. You can see on the ground plane I've learnt from last time, and I've reduced the spoke width to 0.5mm for the thermal relief on the ground pads. This should make soldering a bit easier for me. So if we take a look at the bottom layer, you can see here I've got GP0 and GP4. They're just feeding into the resistors that go to the base of our transistors. These are just a couple of lines going from the current limiting resistors on the LEDs down to the actual LEDs. And then through from the LED to the collector on the transistors. And then these are the base of the transistors, the lines going into the base of the transistor. And this is here is what I've had to do with that isolated ground pad. I've just had to put a little line in here because this ground pad here is isolated, so I'm just linking it across to the other one. Just make sure it is connected to ground. Not totally happy with that, but I think it'll be fine. Then up here we've got our I2C lines. We've got SCL and SDA for the clock and data lines, again at 0.3mm. This is the A0 line going to our little jumper selector here, and then this is the reset line going to the pull-up resistor. And that's about it on the bottom routing. So that was all the routing. It was fairly simple in the end. I think I've got a fairly neat layout. I'm quite happy with it. Not totally happy with the silk screen here. Some of these resistors are rotated around, although the resistor doesn't matter which way around you connect them, but you do have to have them matching your schematic. So I had to rotate them, and I found the silkscreen didn't quite line up when you rotated them. I did also have to modify the silkscreen manually on a couple of these capacitors here, C2 and C3. They seem to have very large rectangles on the silkscreen. It looked ugly and went off the edge of the board, so I've customized it and just put my own rectangles in there. I've put some text in here for all the pin headers so we know what all the connections are, and another one here for the A0 jumper. So we can take a look at here at a nice 3D rendered view. I think this is looking quite smart. I'm quite excited about getting this built. I hope it looks as nice as it does in this 3D view. So up here we've got our power supply and our voltage regulator and a couple of capacitors. The main chip with its capacitor going to the VCC pin. And we've got our LED circuits here, two of them, two identical. Our header pins all labelled up. And again on this side, we've got a couple of pull-up resistors on our A0 jumper selector. So I'll head over to the JLCPCB website and we'll get these boards ordered. So you can see here we've got a price of £1.49 and shipping £3.86. So nice and cheap. I've stuck with all these defaults, quantity of 5. It's on green. I'm thinking about going with the default colour of green. Unfortunately, the Easy EDA software only allows you to view the board in blue on the 3D view. So I don't know what these are going to look like in different colours. I don't think I like the yellow. You can see here we've got red. That might look quite nice. I think I'm just going to go with the standard green. So I've selected specify a location for the order number because they always put that on your boards. So we'll go ahead and order that. I always select the GB special airmail delivery. I think that's the cheapest option. You can see we've got a total of £5.34. So then it's just really a case of waiting for about 15 days for them to be manufactured and shipped to me. And here we are, roughly 3 weeks later. If you've been watching my mailbag video, you'll know that these arrived. So as usual, they're the pretty good standard that we get from JLCPCB. So I'm really looking forward to soldering this together. Got plenty of these here. I laid them out so that there was 6 on each panel, and we've got 5 panels, so there's 30 in total. So not quite sure what I'm going to do with all of these, but if you're interested in getting one of these, please let me know. So I think what I'll do is I'll get straight on and solder this one together. I've got some new solder to try out. This is a multi-core 5-core solder, 6040 tin lead, so this is actually leaded solder, so this should be a little better, and it's a little smaller diameter than I've been using before. This is 0.7. I actually wanted to get something even thinner, but I found this multi-core solder really difficult to find in the UK. I don't know where we can buy this from, and it's really quite expensive, and you really don't get much on there. I thought we'd give this a go and try this out, see if it makes the soldering a little easier. So we'll start with the two 10k pull-up resistors. I'm actually using a brand new soldering iron tip, which is a really fine one. What I really need is a new pair of eyes, because I can barely see this. looked like, but it felt really nice, flowed really well. So next up I've got the resistors for the base of the transistors. They're both 22K. Okay. And then finally we've got the current limiting resistors for the LEDs, 470 ohms. Next up I've got the little 10 nanofarad capacitor. It's on the output of the power supply. Now I've got the voltage regulator and the two transistors, and we have to look at the numbers on these because they're all in the same package and they all look the same. I think that's the 547. I'll solder that on because I've got it in my hand. I think generally when you solder these transistors on, you just leave them away from the circuit board a little bit. I don't know if people have preference to push them right down. I think you can, if you want to, you can push them so that they're right flat, but I think I generally see them standing up a little bit. I guess I don't know if there's any reason for that. I don't know if it's personal preference. Okay, this is the next transistor. This seems to be the one I've picked up, so that's the one I'm going with. Okay, so then this one must be the voltage regulator. Yep. So next I've got the LEDs. Gone with 3mm LEDs. I could have used 3mm or 5mm. They both fit on this board. I thought the 3mm ones looked slightly nicer. Now we've got to get these around the right way. So I guess the leg going to the current limiting resistor must be the positive, which I believe is the longer leg. If they don't work, we'll have to just remove them and redo them. They should have really been done before the transistors because they're not quite as tall. This might be a little tricky. I'll put a little bit of tape on the back of them to hold them in. Struggling to hold the board still while I solder, so I've put it in a little clamp, in a little vise, but I don't like that because I can't rest my hands on it as nicely. It does hold it steadier. Just wish it was lower to the bench. Yeah, I think that worked. I think they're on there nicely. So I think we've just got one more capacitor here. I've got a bit of a problem with this one. Let me show you that. I've got a couple of different capacitors. I've got some larger sort of ceramic disc ones that have the legs further apart, and the way I've designed this board, I've got the holes quite close together on here, so I'll have to think about that in the future if I do any more boards. So we actually want a capacitor with the legs close together, and I've got this one where they're kind of close and then they spread out, so I'm going to see if I can straighten them and get them in there. Okay, I butchered it a little bit. I think it will go in there now. I'm going to do one each end and then just check that I'm happy that it's straight. Yeah, I think I'm happy with that. Not sure about those two. Looks pretty good. Then we've just got two pin headers to put on here by the looks of it. No, just one. For the address selection, just here, A0. Okay. A little awkward. Now I've cleaned the flux off with a bit of isopropyl alcohol, and then I'm just blotting it with some tissue paper. I can actually see that there's a lot of yellow stuff coming off, which I'm assuming is the flux. It doesn't look particularly clean. Perhaps I should do it again, but it's clearly taking something off because I can see it's coming off in yellow. There we go, that's that. So the last thing to do really is to just plug the chip in. Okay, just making sure all the pins are straight before I actually put any force on it. There it is, the finished board. I'm pleased with how it looks. Whether it works or not might be a different matter. Let's power this thing up and see how we get on. So I've loaded a little sketch onto the Arduino, pretty similar to one I had before, but this time I've got it controlling both of the GPIO pins that are connected to the LEDs, so we can see both LEDs working. So I think that's a nice little test for the board, and we can see here it is indeed working. I don't really want to touch it because I haven't really got a very good connection on this battery that I'm powering it from, but you can see that the concept works. So I'm really pleased with that. This is really the first circuit board that I've designed and fully assembled. I have designed a couple of other circuit boards before, but not really put them together yet. So I'm pretty happy with that. I think what I'll do next time, I think we'll have a part 4, and what I'll do next time is we'll actually connect up a breadboard here with some real circuits for the I/O pins here to control. So again, that will probably just be some LEDs, but we can have up to 8 of them. But I think it would also be nice to demonstrate how we can use these pins as inputs and not just outputs. So perhaps we could have a couple of buttons and a couple of LEDs, and we can see that when we press the buttons, the LEDs come on, just to demonstrate that we've got both input and output. But as it stands, I'm really happy with that. It's all working. I think the concept has worked out quite nice. So I'll leave it there and hopefully see you next time. Thanks for watching.